So the presentation is about a project I have started, I think it was last year, but it's actually based, as we will see during the presentation, on a previous iteration, previous technologies. So let's dive directly into it. It's a project with the goal of empowering everyone, every small company, every maybe larger company, even individual, with a greater control of their technological sovereignty or digital sovereignty. So what is the challenge? The challenge is, as we've discussed and as we will discuss again in a few minutes, digital sovereignty. In Europe especially, we understand that there are many dependencies. We depend on American technologies. The fact that they are American can be important if you look at the geopolitical context, but it can also be a detail. Maybe you think that the main issue is that you depend on software, hardware, technologies, and digital services that are developed and operated by a large corporation, and that the rights of the individuals or the small companies or even the governments are not they don't align well with the rights of these entities. But the problem is that if you want to get rid of these dependencies, there are many difficulties. For instance, the complexity, as you see in the picture, it can be quite difficult at one point. If you don't have much time, if you don't have much expertise to really install, develop, operate from scratch all the technologies that are needed for your organization or for your individual needs. So it's also a time burden, and there can be security issues if you are not a security expert. What will happen if some hackers get into your system? There is a very nice model that was invented 30 years ago, approximately, by organizations like Debian, Red Hat, Slackware, and so on. It's the Linux distribution model, where in a Linux distribution you have the kernel, you have the system utilities, but you also have gigantic collections of software. But usually it doesn't work. It works well for many kinds of software, including desktop software, including networking, infrastructure, and so on, but it doesn't work well, at least until now, with SaaS, web application, which is now essentially the norm if you want to have an application that is collaborative. So I'm introducing the solution right now. It's called Hop3, the open source platform as a service, and it's supposed it's designed to address all these issues. It manages the life cycle of your applications. That's the main goal of the platform, from building the application, deploying the application, maintaining over the course of the lifetime of your application, securing it, and providing some resiliency in the form, for instance, of backup. It empowers you with a much greater control on both your application and the data that is managed by your application. So let's keep a bit. Yeah, there is the famous DevOps infinite loop. So you have the same keyword, build, deploy, run, secure, monitor, and test in a much in a familiar fashion. And so what is the state of the project? So right now we have a single system that can be deployed on a single server. And it's mostly a command line interface. You use a git push to deploy an application, and then it will build the images, it will build the application, it will deploy it, and then you have a set of commands to manage the life cycle. But as we will see in a few minutes, there is a short-term roadmap, at least a short-term roadmap, where we'll provide a significant improvement thanks to a couple of R&D projects, and I will give more details in a few minutes. This is a conceptual diagram where we see once again all the key ideas, and then all the ways the project will address these various concerns. So what are the core principles? It's a 12-factor application. Well, it's supposed to work with the 12-factor principles, which were, I think, created by Heroku, one of the first platform as a service, and probably the most well-known. I think it was 15 years ago, probably. The 12-factor is a set of principles that are currently being updated, but that are mostly still relevant today, and also there are new principles. So we have not 12 factors now, but I don't know, 18 or 20 factors that are key to our vision. Of course, the values of the project, sovereignty, inclusivity, efficiency, and so on. And it's an open source project which is supposed to have a low barrier of entry. So unlike other technology, a single server, a small server, even a Raspberry Pi or a single small VM should be enough, at least to get started with actual and useful deployment. So the tech stack is quite simple and also quite accessible. It's based on the Python programming language, and it uses some of the classic technologies like Docker, or not necessarily Docker, the OCI container standard. It's always better to base your project on a standard than on a specific implementation. In the future, we are going also to work with NICs, but it's not the core part at the moment, and we still will need to develop this part. So the configuration of all this application is purely declarative. Of course, there can be scripts and that are executed at one time or another, but overall, it's declarative. You declare your application, or a developer declares all the needs of your application, and then you develop it, and the system then manages it itself. Okay, so it's not a project that has completely been started in the void. There is a long history of similar projects, including the Freedom Box, for instance, that was started by, I think, maybe not the Free Software Foundation, but the Freedom Conservancy, or one of the large organizations that are related to free software. 15 years ago, I think, or almost 15 years ago, Unost, probably some of you, who knows Unost in the room? Okay. I'm not even sure you should call it Unost. Some call it why Unost, but I call it Unost. I think it's quicker this way. So NUA was a previous iteration of Hop3, but based on a slightly different paradigm. And Piku is a clone, a small clone of Heroku, which is programmed in Python, and initially was intended to be deployed on a Raspberry Pi, hence the name Piku or Piku. So we are using the many concepts from this project, and sometimes we are even reusing codes, for instance, from Piku. But we are improving on the existing situation by having a plugin architecture. So the plugin architecture is very important to be able to address many different technologies and many different deployment scenarios, from one single server to several servers, from Docker or OCI-based deployment to non-OCI-based deployment. Various programming language, of course, we are supporting Python, PHP, Node.js, Go, Rust, and a few others. But if you want to deploy an application in Common Lisp or in Racket or in, I don't know, some exotic OCaml or language, it will be possible by just providing an additional plugin. So what are the use case? So currently we are dogfooding the system, using it for our own IT, internal IT at Abilian, and also for a few external websites and application for our customers. But the target is first SDO, software developing organization, and for this reason we intend to provide a set of open source web applications that are relevant for development teams, like bug trackers and so on, as you can expect. SMEs, or small administrations, like local councils, that effectively need similar application, not the same application, but there is a set of applications that can be very common, like productivity suites and communication and marketing and automation and websites and so on and so on. And the last item, which is actually the first item where we actually got revenue, is R&D collaboration, because, as I will present, we got some funding from two R&D project or funding schemes. So the key feature, some of them not ready yet, but at least that's where we are going to. Everything must be as simple as possible. We need to be able to manage users and their rights within the system. The resilience, usually, at least the first step to resilience is to have backups and to be extra sure that when you have a backup, you can restart a new infrastructure from the backup, logging, monitoring, etc., etc. So the web management interface, for instance, is not ready, but this is one of the next items we will be working on this summer. So no demonstration, sorry, but I only had the slide, so it's just a screenshot of the demonstration with the hop command, which is the main way to interact at the moment. So you can list the application, you can start, stop, backup, delete, and monitor, and get access to the logs and so on. A very simple deployment scenario where we don't even have a configuration file, or at least a specific configuration file for Hop3. We only have what is called a proc file. A proc file is a loosely defined standard for this kind of situation where you want to deploy an application. The proc file is very simple, only one line, and by pushing using Git, but we also could use the hop command. By pushing, you get your website running in a few minutes. Okay. So what's the roadmap and what are these research projects I was talking about? So at the moment, we are transitioning from one version to a new architecture. So the previous version, or the stable version, is a single. There is only one command that runs on the server, and is called from the client, from your desktop, for instance. But the new version will be server-based, so there will be at least that's the version we are working on at the moment. There is now in the current development branch of the code a server, and then you interact with the server with your command or with the web interface once it will be ready. You can, at least at the moment, deploy not yet on Nix, not yet on SlapOS, not yet on various technologies, but that's the aim for very soon, actually, at least for some of them. And then we will work on scaling, placement, etc., etc. And security, I think it's very important to be able to provide some kind of firewall. I know it's not perfect, especially when you don't control anything, everything, but having a front end that will filter some of the unwanted users, at least it provides the first barrier to prevent nefarious usage of your application on nefarious access. Okay, so what are this funding we currently have? So currently, or initially, the project was self-funded by my company, Abilian. But we received this year two major, at least at our scale, two major funding from NGI 0. So as you know, this RWCon is also NGICon. There are several events related to NGI. So thank you, NGI. And there is another cascade funding scheme, the NEPHELE project, where we also got funded. So with the NGI project, the goal is first to be able to integrate NICs, because they are very fond of NICs, into Hop3. First for building the application, NICs, of course, as you know, if you are familiar with NICs, you know that the main selling point is reproducible builds, so the ability to, with a given configuration, be able to reproduce exactly the same software, executable or artifacts at any point in time, at least as long as the source code is still around. Okay, a second item in this project is to secure the supply chain. As you know, there is the CRA. That's a big, and it's not just the CRA. It's the global context where cybersecurity has become very important. And we will try to integrate with the best practices and as well also provide this active firewall I was talking about a few minutes ago. Security by design. So NGI Zero Common provides some help with security. So we will also work with them on security. I'm being quite quick because it's already over. And then the second project, which is called NEPHELE, a large consortium. And they have this idea of deploying application using Kubernetes, but using also some technology, open source technologies, of course, they have developed on top of Kubernetes. They call it the SMO, the Synergetic Meta Orchestrator, which provide additional support for placement and scaling and so on. So we are currently integrating with them, and yeah, it's ongoing. Because why? Because they have a very strong deadline, and that's the reason I'm so quick. And I have also a very strong deadline now because I have to finish the talk. But it's over. It's the last slide. As you know, in every conference, you have to present this slide and join us. Of course, this is an open source project. It's evolving at a quite very quick pace at the moment. But the idea is what? As I said, plugin. Plugin, it means extensibility. So it means at one point, everyone will be able, once we've stabilized the APIs and the plugin system, but everyone will be able to create new plugins for their favorite language, for their favorite database, for their favorite orchestrator, operating system, and so on. So that there are many integration points that are possible, and we really hope that some people in the community will be interested in contributing either to the core of the project, but also through plugins, which is probably the best way to be involved in a project like this one. So, yes, there are some resources. The source code is on GitHub, but also on other repositories. The documentation is on hop.cloud. It's not hop.cloud, it's hop3.cloud. I think I made a mistake, so maybe you should try it. It's either this one or hop3.cloud, I think. And the takeaways, yes, a solution for self-hosting I think self-hosting is both something a bit niche, but I think it's something that many both people and organizations are still considering nowadays, even in the cloud era. Sorry, digital sovereignty, as I said, very important topic nowadays. It's free, it's open source, and it's really related to the idea of ecosystem. Just like a Linux distribution can be a standalone project, as Linux distribution is a community project. And I think that's almost there. Yeah, you have the final takeaways, and I leave you with the takeaways, and I seek it's over